Welcome to today's presentation on transport protocols. So the transport layer is a critical component of the OSI model, responsible for ensuring reliable data transfer between devices. So a transport layer is the fourth layer of the OSI model, and it provides the following services. I'm going to explain the services that are provided by the transport layer. The segmentation, that is breaking down of data into smaller segments for transmission. There is connection establishment. This one establishes and manages connection between devices. There is reliable data transfer. This one ensures that data is delivered accurately and in the correct order. Then there is flow control. This one regulates the amount of data that can be sent at one time. So the transport layer protocols, we see there are two primary transport layer protocols. The transport control protocol, this one is a connection oriented protocol that ensures reliable data transfer. There is a UDP, a connectionless protocol that provides best effort delivery. So when you're talking of connection oriented protocols, we are talking of protocols that establish a connection before data is sent. And you see there are three key features that I gave on the screen. There are four actually, the other one on the next screen. So there is reliable delivery that ensures that data is delivered accurately and in the correct order. This one guarantees that your packets are delivered in order and without errors. Then there is flow control. This one regulates the amount of data that can be sent at one time. This one manages the rate of data transmission to prevent overwhelming the receiver. Then there is connection termination. Here ensures that connections are properly closed. So this one properly closes the connection after transfer. Then there is connection establishment. This one is a handshake process. The TCP three-way handshake is required. If you look at the picture on the screen, you see that this one there is a client and then server, right? And this one ensures that both the devices are ready to communicate and establish the parameters for the connection, right? So if you see that there is a state change to synchronize send, right? That one written in red. There is an arrow that is going there that is written SYN. So this is the synchronize. The client device send a synchronize, which is the SYN given on the screen, packet to the server device, right, to initiate the connection. So the synchronized packet contains the sequence number. If you see at the screen, there is a CSEQ 100, right? So the sequence number, which is a random number chosen by the client, in this case this is 100. Then you can also check there is a source. There should be a source port, the port number of the client and the port number of the server. Then you see the arrow, then there's the state changes to synchronize receive. Then from the server we see an arrow that is going to the client, and you see that there is a SYN ACK, which is the synchronized acknowledgement. The server device responds with a synchronized acknowledgement packet, which acknowledges the client's synchronized packet, right? And you see that it also sends its own sequence number, a random number chosen by the server, and it confirms the connection, right? Indicates that the server is ready to establish the connection by that ACK 101. Then you see that the state changes to establish on that client. Then there is an arrow that is going to the server that has got an ACK, which is an acknowledgement. So the client device sends an acknowledgement packet to acknowledge the server's SYN or the synchronized acknowledgement packet. right? This packet acknowledges that the server sequence number, the sequence number, and there is a sequence that is 101, so there is an acknowledgement there. Then this completes the handshake, confirms that the connection is established, then a state changes to established, right? So the importance of this three-way handshake is that there is connection establishment. Both the devices agree to establish a connection before the packet is sent. Then the sequence number synchronization. Both the devices agree on the sequence number for the connection. Then there is error detection. This handshake detects errors or inconsistencies in the connection setup, right? Connectionless oriented protocol. So connectionless protocols do not establish a connection before data is sent, and the key features are given. There is no connection establishment. Data is sent without establishing a connection. So data is sent without a handshake process. Then there is the best effort delivery. Data is delivered without guarantee of accuracy or order. So there is no guarantee of order, reliability, or error correction. Then there is low overhead. UDP is lower overhead compared to TCP, typically faster due to the lack of connection management, right? But it's not reliable. Then there is a stateless communication. UDP does not maintain connection state. Each packet is treated independently. For fields, and these are the fields that I was explaining, right? So this transport layer protocol, and this one is a connection-oriented protocol. Means that the connection is established between both ends of the transmission. So for creating the connection, TCP generates a virtual circuit between the sender and the receiver for the duration of a transmission. And the features of a TCP, there is a stream data transfer. This one transfer data in a continuous stream. There is the reliability. TCP ensures a reliable data transfer because of the three-way handshake that we explained. There is flow control. TCP regulates the amount of data that can be sent at one time. Then there is multiplexing. The TCP allows multiple applications to share the same connection. Then there is a logical connection. TCP establishes a logical connection between devices. Then there is full duplex. TCP allows for simultaneous data transfer in both directions. This one you can see there is a transport layer protocol, and the steps that the following steps occur: establish a connection between two TCPs. Data is exchanged in both directions. The connection is terminated. This one uses the three-way handshake that we explained earlier. Then if you look at this, you see that TCP segment consists of, there is a source port, right? This is the port number of the sending device. Then there is a destination port number. This one, the port number of the receiving device. Then there is a sequence number. This is the sequence number of the segment. Then there is an acknowledgement number. The acknowledgement of the segment. This is the acknowledgement number of the segment. Then there is offset. This is the offset of the segment. Then these are reserved bits. Then the agent point. This is the agent point of the segment. A checksum. A checksum is used to verify the integrity of the segment. The options or padding. These are optional fields and padding. Then there's data. This one is the actual data being transmitted. Then also when comparing the TCP versus the UDP, the TCP has got a three-way handshake. This means that on TCP there is connection establishment. The TCP establishes a connection like what you're seeing on the diagram, the synchronized acknowledgement and the acknowledgement. So they establishes a connection before data is sent. So while UDP doesn't, right? Just to send the request, then a response is given to the receiver, right? Then there is reliability. TCP ensures a reliable data transfer, while UDP provides best effort delivery. Then on flow control, it said that TCP regulates the amount of data that can be sent at one time, while UDP does not. Overhead. On overhead, the TCP has higher overhead compared to UDP. So in conclusion, we are saying that is a critical component of the OC model. It is responsible for ensuring reliable data transfer between devices. So TCP and UDP are two primary transport layer protocols, each with its own strengths and weaknesses that I mentioned during the presentation. So understanding the features and differences between TCP and UDP is essential for designing and implementing efficient and reliable networks. Alright, so if you have questions, you are free to ask in the comment section. If you have comments, just comment in the comment section. Thank you for listening to this presentation.